This is lesson 55, BHDL example 33. You remember in lesson 54 we saw how to design a logic circuit for a 4-bit multiplier. In the next lesson we will actually implement that in BHDL, but there's a special case of multiplication, that is multiplication by a constant, which is very important. And we want to cover that in this lesson. Suppose you want to multiply any number by 100. Now, any constant you can write as powers of 2. For example, 100 is 64 plus 32 plus 4, which is 2 to the 6th plus 2 to the 5th plus 2 squared. So it turns out that all you have to do is shift to multiply by 2. Every time you shift left, it multiplies by 2. So if we shift 6 places to the left and then add it to the same value shifted 5 bits to the left and then shifted 2 bits to the left, then that will be the same as multiplying by 100. So here's a BHDL program to do it. Let's take x to be a 9-bit number, 8 down to 0, and we'll have the product. If you multiply by 100, the product won't be bigger than 16 bits, so we'll make the product 15 down to 0. And here's all you have to do. You say P gets x shifted 6 bits left. Well, you remember how you shift 6 bits left? We're just going to add 6 zeros to the right, and we'll add a leading 0 here to make it a total of 16 bits. Then we add that to x shifted 5 bits to the left. Well, to shift 5 bits to the left, we just add 5 zeros. We add 2 leading zeros, so the total number of bits here is also 16. And then we add that to x shifted 2 bits to the left. So we add 2 zeros to the right. That shifts x 2 bits to the left, and we'll add 5 leading zeros to make this one 16 bits. And you just add them together. So shifting is just basically rewiring, you remember. So basically just 2 adders here will allow us to multiply any number by 100. So this uses much less hardware than the multiplier circuit we had in the last lesson. So anytime you want to multiply by a constant, you should use this technique. We can test it with this simulation. Here I've made a binary counter. These are hex numbers 23 and 39 4F. These correspond to the decimal numbers 35, 57, 79, 101, 123. And if you multiply by 100, you should end up with 3,500, which is DAC. You can check that. 5,700 is 1644, and so forth. So in fact, this technique succeeds in multiplying any value by 100.